Welcome back, folks. This is Daniel for Rock the JVM, and this video is the third part of the mini bank application using Akka, Cats, and Cassandra. So over the previous two videos, which I recommend you check out, we wrote the important actors of the application, and in this video, we're going to write an HTTP server using Akka HTTP to interact with our actor combination, and we are going to also test everything. So grab the code that you wrote over the past couple of videos, and let's continue. Cool, so here under the HTTP package, I'm going to create a new Scala class. I'm going to call this bank routes and or router. And this router here will define all the HTTP API that we're going to use here for this server. So routes or router, name it however you want it. And here under the bank routes, I'm probably going to pass some arguments because I'm going to first assume that I'm going to have access to the main bank actor. So I'm going to call this bank as an actor ref of type command. And I need to import command from our own package. So here from Rock the JVM bank actors persistent account command. And I also will probably import the rest of the commands here. So all the case classes that extend command. So at the least, I'm going to require this actor ref because I'm going to interrogate it. And I'm going to define my HTTP REST API. So the API goes as follows. First of all, I need a post at / with a payload, which is a bank account creation request. So if I post at / I might actually create a prefix, so bank / I'm going to have a bank account creation request as JSON. And the happy path is going to be, as a response, we're going to have a 201, which is created. And I'm going to also reply with a header that will contain the unique identifier of the bank account. So I'm going to have to reply with a location, which is /bank / the UUID of the bank account that was just created. And as the logic, I'm going to send a message to the bank actor. So let me go ahead and do that first. So I'm going to import the Akka HTTP directives. So import Akka HTTP Scala DSL server directives plural. Okay, this will add all the DSL of the Akka HTTP API. I've discussed Akka HTTP in another video here on the Rock the JVM channel. And I'm going to define my routes. So I'm going to have a val, let's call this bank account, or simply routes, and I'm going to use a function called path prefix, because I'm going to use this bank token here at the minimum. So I'm going to have bank here. And under path prefix, I'm going to nest other routes. So if the path prefix matches, so if the HTTP request has the path that matches bank, then the bank prefix will be stripped and the rest of the stuff is going to be parsed. So I'm going to check for path end. So if the path prefix matches, then I will require the Akka HTTP DSL to match the path end, or the single slash, so or single slash. And I'm going to also match the HTTP method. So I'm going to use the post directive. So if the path prefix matches bank, if after that we follow the end of the path or a single slash, then if the method is post, then I will try to parse the payload. And so I'm going to have to parse the payload. I will have to define one. So I'm going to define a quick case class that will define a path, a bank creation request. So I'm going to have a case class. I'm going to call this bank account creation request, or create request if you wanted to use that notation. I'm going to have a user as a string, a currency as a string, and the balance will be double. So this will closely resemble the actual command to create the bank account. So the user currency initial balance, and this will be filled by me. Okay, so I will try to parse as JSON the bank account creation request as a JSON object. So I will need to add a bunch of imports so that the JSON parsers can run automatically. And here under build.sbt, I have a bunch of libraries here. So I'm using Circe for JSON serialization and deserialization, and this Akka HTTP Circe for compatibility with Akka HTTP. So I'm using these 4 libraries. And in order to parse the HTTP JSON payload correctly, I'm going to import IO Circe generic auto, which creates JSON parsers and serializers for all case classes. So this is based on macros, and this case class will be automatically convertible to JSON and from JSON. Now, in order to add the Akka HTTP compatibility, I'm going to also import, and the prefix is d.heiko-seeberger. So I'm going to have d.heiko-seeberger, Akka HTTP Circe, and I'm going to use one of the implementation here. I'm going to use fail-fast Circe support. So I'm going to use everything here. And this will allow me to use a special directive called entity that will allow me to parse the payload directly into the case class that I want. So I'm going to use the entity directive, so entity. And inside the entity, I'm going to say as bank account creation request. And if the entity as bank account creation request was successful, meaning that the JSON payload was correctly parsed, then this directive will give me back the request as a case class, which is very, very powerful. So the bank account creation request will be available to me, and I can do something with it. And I need to do a bunch of things. First of all, I need to convert the request into a command for the bank actor. Because this is a simple case class, I need to map that to a command that the bank actor can understand. So that's the first thing that I need to do. Then I need to send the command to the bank. And then I will expect back a response. So expect a reply. And then I will parse that reply or use its data to send back a response. So an HTTP response. So notice that there is a little bit of a journey that we need to complete here. Now, the first 3 steps to convert to send a command and expecting a reply is not really part of the route's logic itself. So I'm going to abstract these 3 away into a method. I'm going to call this, let's say, create bank account. And the bank actor is available to me, and I'm going to simply pass a bank account creation request. So this is the request as a bank account creation request. And I'm going to expect back a future of response. And first of all, I need to import future, and also the response type, which is here. I'm going to copy this import, and I'm going to import response as well. And I'm going to leave this unimplemented for now. So the create bank account method will run the first 3 steps. First of all, convert the request into a command, send the command to the bank, and expect back a response. Now, assuming that I have a response, I need to send back an HTTP response. So I'm going to run an onSuccess directive. And the onSuccess directive has a type that is pretty useless because the Akka HTTP DSL uses the magnet pattern. I'm going to simply use create bank account on this request, and the magnet pattern will take care to transform this future into the appropriate internal types of Akka HTTP. And onSuccess will take a case for all the responses that I might need to treat. And in this case, for the bank account creation, I only expect one single response, which is the bank account created response. Created response with an ID. Now, I also need to import all responses. So I'm going to copy this one as well. So response everything. And now I have access to the bank account created response, which is the message that the bank actor sends back to me. Okay. And I will fulfill that as a feature, and I'm going to show you how we can do that with the ask pattern. So assuming these first 3 steps were completed successfully, which is what this directive does, considering the response, I need to send back an HTTP response. So I need to complete with a directive which is called respond with header, so that I send back this location thing, which probably the browser will need to parse and then access another web page or something like that in the let's call this online bank application. So respond with header, I'm going to use the header called location that we have here under Akka HTTP Scala DSL model headers. So make sure you import that one. So location will be used or applied with a string. So I'm going to use /bank/ and I'm going to use the identifier. So this is the unique identifier of the bank account, and this is the header of the final HTTP response. And the payload itself is going to be a complete directive, complete with status codes. This is the way of putting an HTTP status code. So status codes dot 201 created. So you have variables here for all possible HTTP responses, and we have here created. So created is a simple constant that returns HTTP 201. All right, so this little magic says that if the HTTP request has the path prefix bank, then after that we have path and/or single slash. Then if we have the method called post, then if the payload was successfully parsed as a bank account creation request from JSON, then given the request, if I can create a bank account through this method that returns the future response, then if I have a bank account created response with a potential identifier, then I will respond with this particular header with status code 201. So there's a lot of if-then logic here in this structure. All right, so to order my little messages here, this thing should stay below. All right, so we're following the logic here, and I'm yet to complete this create bank account method. Okay, cool. So the create bank account will take a request, and it will return a future response. Well, I'm going to first transform this request into a command. So I'm going to add a small method here under the request. I'm going to call this toCommand. That will contain a reply to actor. So reply to as an actor ref of command, an actor ref of response actually, response, because this actor will be used as an intermediate actor which will store the response from the bank actor, and this will also fulfill the appropriate promise. So this will return a command. And this is going to be a bank account command. So create bank account with the same data, which is user, currency, and balance, plus the reply to actor as the 4th argument. Cool. So I can transform this HTTP request into the command that the bank actor can understand, which contains the reply to actor that will store the response. Cool. So I'm going to run an ask pattern. So I'm going to, first of all, go ahead and import that. So I'm going to import Akka actor typed Scala DSL ask pattern everything, which will give me the extension methods necessary. So I'm going to say bank.ask. So the bank is the big actor that will have the entire hierarchy, and bank ask will take the lambda from a reply to, so the reply to actor that is being built automatically, or the intermediate actor. I'm going to pass a request, so request.toCommand on this reply to actor as an intermediary. So the bank will be sent this command, which is obtained by calling this method, and the response will be stored in this intermediate actor, which will fulfill the promise. So that's the general gist about it. And we need a timeout and a scheduler, which can be found by adding an actor system as an argument. So I'm going to make this implicit. I'm going to call this implicit system as an actor system. and I don't care about the type of the actor system. And once I've made the system implicit, I only need the timeout because the system implements the scheduler interface. So I'm going to define an implicit val timeout of type timeout from Akka util, and this is going to be a timeout of, let's say, 2 seconds or 5 seconds or something. Cool. Now the seconds method needs to be implemented, so I'm going to import Scala concurrent duration everything, which unlocks the seconds extension method. So given the timeout now, and given the system, we can run the ask pattern on the bank. So this endpoint is created. All right, let's do the other endpoints. So we said we would get at /UID, but because I added the bank prefix, I'm going to have /bank/UID, which is the unique identifier of a bank. And this will not get any payload, so this is a plain GET request, and as a response, we should get a 200 OK and the JSON representation of a bank account. So this is JSON representation of bank account details, which is pretty much the same as we did earlier with a persistent bank account, which is, where is it? The bank account with the ID, user, currency, and balance. This is the thing. Now, for this one, I don't need to create any case classes because I don't have any payloads. So I'm going to simply chain the current route here. So at path prefix bank, so right underneath path and or single slash, I'm going to chain that with a little tilde operator, which means that if the path and or single slash was not matched, then we will try the next route. And I'm going to use path on a token that's called a segment. And segment needs to be imported from Akka HTTP Scala DSL server path matchers. And this is an extractive directive, meaning that this segment, which is the next token after /bank, will be parsed and it will be returned back to me in the form of this unique identifier that I'm going to then use. So let me go ahead and describe the flow real quick. So first of all, I will need to, well, I don't need to parse the payload. I do need to find the bank account actor. So I'm going to send a command. So send command to the bank and expect a response. So expect a reply from the bank and then send back the HTTP response. So pretty much a similar flow as before, whereas here I don't really need to parse the payload. I only need to create an analogous method called, let's call this get bank account, which takes an ID as a string. And this is a future of response, just as before, so response. And I'm again going to use the ask pattern. This time it's going to be easier because we have all pieces in place. So I'm going to have bank ask, and given an intermediate reply to actor that Akka will create for me for this interaction, I'm going to create a get bank account message with that ID, so with the ID of the bank account that I would like to find, and this reply to actor, which will be used as a short lifespan actor, which will then complete this future response. Okay, so get bank account will then be used here as to send a command and expect a reply. So these two were completed here in this first step, and then I'm going to send the HTTP response shortly. So I'm going to again call on success on get bank account with that ID. So this is the directive, and in case we get how's that response called? We have get bank account response. So we'll have get bank account response with a maybe bank account. And here I might want to parse the maybe bank account and deconstruct it further. So I'm going to have a sum with an account. Then I'm going to complete with that account. Because the account is a data structure, therefore it can be parsed to JSON. And in case we get a get bank account response with none, that means the account was not found. So I'm going to complete with the status code not found. So status codes dot not found. And I'm also going to run a small payload here to describe the error that occurred. I'm going to go at the top and create a case class. Let's call this failure response that contains some reason as a string. So I'm simply going to create a small case class, and I'm going to use this failure response here as the second argument. Let's say bank account, and I'm going to inject the ID, cannot be found. Something like that. Cool, so this was the second endpoint. So we parsed the segment, which was the next token after /bank. So this will be the unique identifier. I'm using that to fetch the bank account as the interaction with the bank actor as a ask pattern. So I'm going to use the ask pattern here, and the interactions happen automatically. And then we are going to simply parse the response as a get bank account response with some account, and this will be a data structure. If this is found, I'm going to complete that in the HTTP response. Otherwise, I'm going to complete that with the status code not found. By default, if you complete with a data structure, that's automatically a 200 OK. So that is the second endpoint, which was the get bank UUID. Cool. Now, I want to be able to update a bank account, so I'm going to have a put here. So put /bank/UUID, and we're going to have a payload, which is the new bank account details. So I'm going to have my currency and amount. So currency and amount as a data structure, as JSON. And I'm going to expect a response, and the responses are 200 OK. We have maybe a bad request, and not found if the UID is wrong. So let's have a 200 OK, and new bank account. So payload of new bank account as JSON. So that's one option. Let's arrange this nice. Then we have a 404 not found, which was here as well. So we also have a 404 not found. And we have maybe a bad request if this the currency and amount cannot be validated. I'm going to put that as a to-do here. So let's say 400 bad request. If the request is not being validated, let's say the currency cannot be found, maybe it's a fictitious currency, or the amount is too big, or something like that. So bad request if something wrong. And I'm going to add the this third aspect as a to-do because we don't have any validation logic yet. Cool, so let's treat these two cases for now. So here under path segment ID, we also need the get method. So I'm going to wrap this in a get, and I'm going to put them here. Now, at the same path segment, we also need to handle the put method. So here under get, I'm going to chain the put method. So the put directive. If the method was not get, then we're going to try a put. Now, the put method needs to parse the JSON payload here. I need to create one. So I'm going to create a case class. I'm going to call this bank account update request with a currency as a string and the amount as a double. And I'm also going to, right off the bat, create a command for that. So to_command. And the to_command method will need a bunch of things to be able to turn that into a command, which is the bank account as, this is the response. Sorry, we have an update balance, so we need the ID. So we need the ID, the bank account ID, which is a string, and we also need the reply to actor, which is an actor ref of response. And this will be a command. Cool. So I'm going to create a bank account. What was that? Let's get back to the name. We have update balance. All right. So this is going to be an update balance. with ID, we have currency, amount, and the reply to. And that is the command that I'm going to send to the bank actor. Cool. Right, so let's define the flow again. So we have transfer or transform or parse the request to a command, which we've already done. Then we are going to ask the bank or send the command to the bank. Expect a reply. So expect a reply, and then return or send back an HTTP response. So for this one, we're going to follow the same pattern as the first post. So we're going to parse the entity first. Let's use entity as, and I'm going to have my, bank account update request. So bank account update request. And then considering the request, I'm going to issue a command. So I'm going to transform these three into one method call. So this is going to be to transform the request to a command, send the command to the bank, and expect a reply. So let me go ahead and create a method. Let's call this update bank account, which takes a request. And this is going to be my bank account update request. And this is going to be a future of type response. And this request will also have the ID of the bank account, which is a string. And I'm going to run the ask pattern again. So bank.ask, and considering a reply to actor, so reply to, and this intermediate actor will serve as the placeholder for the future response. So we're going to run a very similar thing. So I'm going to have request.toCommand, because I have the method created beforehand. So request.toCommand on the bank account ID and the reply to actor as the recipient of the message, which will then complete the future response. All right, so this follows pretty much the same pattern as before. All right, so considering that one, I'm going to run an onSuccess. So onSuccess with update bank account on the ID and the request. And just remind you, this ID is being parsed here at the path segment phase. So onSuccess. And in case I get, what was it called? We have responses. So we have bank account balance updated response with an option. So we're going to deconstruct too. So I'm going to have bank account update response updated. Bank account balance update response with a sum account. I'm going to complete that with an account, so I'm going to say complete with the account, which is the latest state of that bank account. And in case I get the same data structure with a none, then that means either the account could not be found. So I'm going to complete with the same thing, complete with a not found, failure response, bank account ID cannot be found. Now, we might want to add some validation here for the request, so that an invalid request isn't even sent to the bank account in the first place. So I'm going to add a to-do here to validate the request. And this will come a little bit later to enhance the logic of our application. But right now, as it currently stands, this endpoint is also valid. So this will send back HTTP response. So let me cut out the comments. So this endpoint is also complete, which brings our whole routes thing to a close. So this will serve as the logic for an HTTP server. So now we have the routes definitions and a bit of logic also there as well. We have some data validation to do, but we're going to do that later. And I'm going to create a main application so that we can actually spin up an HTTP server. So here under Rock the JVM bank, I'm going to create another package. I'm going to call this app. And under app, I'm going to spin up the actual server. So I'm going to create a Scala class. I'm going to call this bank app. I'm going to make it an object, and I'm going to write a main method so that we can run the application as an HTTP server. Cool. Now, in order to run this application, we will need first to create the bank actor. So I'm going to create, first of all, my root actor system. So I'm going to have my root behavior. And I'm going to create that as behaviors, the plural thing. So behaviors.setup. And this is going to be a behavior singular. And I'm going to use not used in this case, because the root behavior doesn't really do anything, at least not yet. So I'm going to create my bank actor. So bank actor as context. Of course, I need to pass the context here. So context.spawn, and I'm going to have my bank thing. So I'm going to import it. Bank, I'm going to call it bank, of course. And this is pretty much it. So the root behavior just spins up the bank actor. Now, I also want to be able to surface that out to the outside so that I can spin up the HTTP server, because if you remember, the bank routes class depends on both the bank actor and the actor system. So we need this bank actor to be able to interrogate it. So get back to the bank application. I'm going to define a small protocol to interact with this root actor system. So I'm going to create a trait. Let's call this root command. And I'm going to create a case class. Let's call this retrieve bank actor, which contains a reply to actor. So I'm going to have reply to as an actor ref. Now this actor ref will contain the response that this root guardian will send back to me, which will contain the actor reference of the bank actor itself. So this is going to be an actor ref of, and the contents are going to be the bank actor, which is again an actor ref. So actor ref of type command. Now the command thing needs to be imported, so I'm going to import that from Rock the JVM whatever. Okay, and this extends root command. Cool. Now, the root behavior here is not going to be a behavior of not used. It's going to be a behavior of root command, because this is the kind of message that the root actor will receive. So the behavior is going to be behaviors.receiveMessage. And in case I get a retrieve bank actor with some form of reply to destination, so reply to actor, I'm going to tell it. So I'm going to reply to this actor. So reply to tell. And then I'm going to send in the bank actor, so bank actor. And then I'm going to return behaviors.same. So this root behavior will be able to surface the bank actor as many times as we like. Cool. Now, I'm going to define an actor system in terms of this root behavior. So val system as actor system with the root behavior as the guardian actor, and I'm going to call this bank actor system or bank system. And I will want to obtain the bank actor from within the system. So I'm going to run the ask pattern again. So I'm going to import, what was that? Akka actor typed Scala DSL ask pattern everything. And let's call this bank actor future as system. Let's put a val here. So system.ask. And considering a reply to actor that Akka will spin up just for this interaction, I'm going to create a retrieve bank account with this reply to. And this is going to be a future of actor ref of type command. Let me import future. And we need to add the appropriate implicits. So first of all, I'm going to make the system implicit, which will automatically implement the scheduler interface. So this is an actor system of type root command. So right now we only have the timeout to add. So implicit val timeout as a timeout that I need to import. And this is timeout with, let's say, 5 seconds. Right, now I need the seconds extension method. So import Scala concurrent duration everything. Cool, so now we have the bank account future. All right, so given this future, I'm going to say bank actor future dot for each, and I'm going to run a small method to create the HTTP server. So start HTTP server, and the HTTP server is going to be a small method for me. So I'm going to have start HTTP server, which will contain the bank actor as an actor ref of type command. And I'm also going to pass the actor system implicitly. So implicit system as actor system of whatever. I don't really care. And this is going to be a unit. And I'm going to add a to-do here for starting the HTTP server. First of all, let's finish this implicit requirement, which is the execution context. I'm going to import that right off the bat. So I'm going to say implicit val EC of type execution context. And this is fetched from the actor system itself, the thread pool. So I'm going to have system.execution context. So bank account future dot for each start HTTP server, and under the HTTP server, I'm going to spin up the actual routes. So I'm going to create my routes or router. Okay, and this is going to be a new bank router. I don't know why the refactor didn't actually rename the class as well. So new bank router with bank, and the actor system is being passed implicitly because this is also implicit in this scope. So new bank router. Now the routes themselves are going to be router.routes. And this will be the logic of the actual HTTP server. So I'm going to have HTTP. I'm going to import that from the Scala DSL. Of course, I'm going to say new server at, and I'm going to use localhost. You can deploy it wherever you want. I'm going to put that at localhost 8080, and then I'm going to say bind routes. All right, and this expression is a future binding that I'm going to, let's call this HTTP binding future. So this is a future that we can monitor for completion. So I'm going to say HTTP binding future on complete. And in case we get a success, I need to import success. So I'm going to say import Scala util, and I'm going to import try, success, and failure. I'm going to import all of them. And in case we get a success with the binding, then I'm going to print something. So I'm going to say system.log.info. I'm going to say server online at HTTP / and I'm going to use the local address. So val address as binding dot local address. And then I'm going to inject here the address get host string, and then colon, I'm going to use the port, so address dot get port. All right. And in case we get a failure with some form of reason as an exception, I'm going to say system log, let's say error, and I'm going to say failed to bind HTTP endpoint or server because, and I'm going to inject the exception here. I don't care too much. And then I'm going to try to terminate the system. So system.terminate. Now, the onComplete thing requires the actor system's execution context. So I'm going to define that here at the top. So implicit val EC of type execution context as system execution context. Right, so that I can run the onComplete callback. And at this point, the start HTTP server method should be pretty okay. So given the bank actor ref and the actor system, we should be able to spin up the HTTP server, and we should start getting some actual requests. Now, I've written quite a bit of code, and there's bound to be a mistake somewhere, and we're going to find soon enough. And cool, let's try running this thing. Let's see. I bet we're closing on to 2 hours already. All right, so we have a bunch of logs here. The log is quite noisy, and if we want to set the log level to info or something, we need to add logback XML and all that kind of stuff. So this is a little complicated. Let's go to server online. Let's search for this one. So we have server online at localhost 8080. This is great. All right, so it seems that our server is running and nothing crashed in the meantime. Now, here under the terminal, I'm going to spin up a new terminal window, and I'm going to issue my first request, which is, first of all, let's try to fetch the details of this bank account. So I'm going to copy this unique identifier, assuming that you can select star from Akka messages and you have this identifier. I'm going to copy that, and I'm going to say HTTP get localhost 8080. Now I've played with this application before while preparing for this video, and we have bank / this one, and we should get a JSON response. All right, so we have an HTTP 200 OK. I didn't expect this to work so quickly. And notice that the JSON says balance 10 USD, ID, and user Daniel. So notice that as soon as this application started, the persistent actors, plural, recovered all the data from Cassandra, and now I can query them and I can surface back a response. This is absolutely fantastic. Now, let's try to see the other endpoints. So I'm going to collapse my output over here. My server is running. Let's go back to the bank router. So we have a post at /bank, and we have a bank account creation request as JSON. The bank account creation request has user currency and balance. So I'm going to issue an HTTP post. Now, by the way, I'm using HTTP for this very handy HTTP command. If you want, you can also use curl. So curl-x get, and you can use the same URL if you want to use the command line. Cool. So I'm going to use HTTP post, and I'm going to use localhost 8080/bank. And HTTP has a very handy way of creating JSON payloads for you so that you don't have to type in all the curly braces and all the quotes. You can specify what was that? We have user currency and balance. Okay, so you have user equals, let's say, Anna, then currency equals EUR for euros, and balance equals, let's say, $100,000 or something like that. So this is the post, and once you parse, or once the HTTP parses all these command line arguments, they will be converted to a JSON argument. Let's see. So we have a 201 created. This is great. And notice that the location header was also sent as /bank/ this unique identifier. We can also check whether the messages were being sent to Cassandra. So if I select star for messages, notice that we have a bunch of data here in Cassandra, which means that the bank accounts were created. Let's get back to this one. And I'm going to do an HTTP get at localhost 8080/bank/ and I'm going to copy this unique identifier. And this is going to be a 200 OK. This is 100,000 euros actually, with the ID owned by Anna. This is absolutely phenomenal. Now, let me shut down the application and let's start that again, just to make sure that both the bank accounts were recovered correctly. Let's see. So the server is up and running. Let's try to run a get again. And we still have a 200 OK. This is great. So the bank accounts were successfully fetched. Cool. Let's try the other endpoint, which was the update request. Now I'm going to try to run an update request on Daniel's account. So I'm going to have, where was that? The DEDA. This is the first identifier for Daniel. So I'm going to have an HTTP put at localhost 8080/bank/ this thing, and then I'm going to try to add some money into my account. So currency equals USD, and amount equals, let's say, $25. All right, so we have 200 OK, and now we get the entire details of Daniel's bank account, which is $35. So that's 10 plus 25, currency USD, the same unique identifier, and user Daniel. All right, so all of our endpoints function quite magically, I might add. Let's try to put a negative amount. So I'm going to try to withdraw $50 from Daniel's account. So I'm going to have an HTTP put at this same URL, currency USD amount, let's say minus 55. And notice that we get a not found. So bank account, this thing cannot be found. Now this is not the right error to throw, and this is quite normal because we're returning a 404. If the updating returned with a bank account balance updated response with a none. Now this can also return a none if the request was invalid. That is, the amount was greater than was required or was acceptable for this bank account balance. So let me try to fetch the current state of the bank account to see if the money was withdrawn or not. So HTTP get localhost 8080/bank/this thing. And again, I have the same $35, so my money is still in my bank account. And let me restart the application to understand whether all of these events were persisted so that all the bank accounts are restored to their latest state. So not with the initial state, but with the latest state. And the Daniel account was modified to $35. So let's try running this again. And we have our $35. All right, cool. Right, so at this point, pretty much at 2 hours sharp into the video, we are going to add a small optional piece to validate requests, and I'm going to use a bit of cats to do that. But that will be a subject for the next video, so thank you for following along so far. Alright, so at this point we have a fully functional bank application using persistent actors and an HTTP server, so the core of the application is more or less complete. So join me in the next video where we're going to create some data validation using cats to make the application more robust. So if you like this video, give me a thumbs up and subscribe because the next video is coming right up.